Welcome to Click My Project. Our project title is Event to Sync Spectrum Aware Clustering in Mobile Cognitive Radio Sensor Networks. Let us see the abstract of our project. The cognitive radio sensor network are an event-based system such that the sensors detect the events and the event reading of the sensors are collaboratively conveying in the multi-hop manner through the vacant channels from the event region to a sync. Hence, the event to sync communication and the dynamic radio environment requiring the coordinate scheme in cognitive radio sensor networks. In this paper, we are proposing the event to sync spectrum aware clustering in mobile cognitive sensor network. The cluster formation takes place using determining the eligible nodes for clustering algorithm. Then finding the neighbor node estimation. The selecting one hop member of the maximization the number of two hop neighbors that are accessible by one hop neighbor through the clustering channel to increasing the connectivity between the cluster. The cluster are between the event and the sync and are no longer available after the end of the event. This avoids energy consumption due to the unnecessary clustering formation and maintaining the overhead. Performance evaluation reveals that our solution is energy efficient with a delay due to the spontaneous cluster formation. Furthermore, we finding the position, velocity, speed, then energy of our nodes in our protocol. Then we finding the performance measures. The performance measures contains throughput, delay, packet delay ratio, and energy consumption of our project. The main objective of our project is to reducing the energy consumption, to finding the neighbors nodes. Then the main objective of our project is an effective cluster formation in spectrum aware clustering protocol to addressing the event sync communication coordinates issues in mobile cognitive sensor networks. Let us see the flow of our project. First one is a node deployment. The node deployment contains node creation. Here I created 13 nodes and one base station. If the neighbor estimation algorithm is used to find the every node neighbor. If the neighbors is founded means then cluster formation. The cluster formation takes position of an every node. The position of the every node is used to create the cluster formation. If the cluster formation is done means then selected the cluster head. The cluster head is selected based upon the energy of a node. Then sends the communication. Check whether if it is a member of the node means sends the communication, otherwise it will not send the communication. The communication is containing the inter-cluster communication and the intra-cluster communication. To check the next best hop in the routing process, then calculating the performance analysis. The performance analysis contains throughput, packet delivery ratio, and delay of our project and energy consumption of our project. Let us see the output of our project. First open the terminal window. So type cd space mcr/rsn folder. The mcr/rsn folder containing our main.tcl file. Now I run the main.tcl file, so I type ns space main.tcl. Now run the process. Here our protocol calculating the each node velocity, speed, then energy of our node. This velocity, updated energy, position, and speed of our process. Now I explain the NAM window. This is rewind button, playback button, stop button, play forward button, fast forward button. This is simulation timing and this is speed. Zoom in button and zoom out button. Now I play the project. Base station is created. The base station is fixed. The base station is nothing but it's in a cognitive radio network. The other nodes are mobile nodes. The mobile nodes in cognitive radio network. Position based clustering is done here. All the nodes are moved to form a cluster formation. Thus, the cluster head is creation based upon the energy of our node. If the high energy of the node is selected for a cluster, the communication is inter-cluster communication and the intra-cluster communication. First, the 4 nodes want to send a communication to the 20th node, so the 4th node sends a communication to its cluster head of 1th. Then the cluster head sends a communication to the base station. Then the base station finds which clusters containing the destination node. Then it will send the cluster head. Then the cluster head sends a destination. Now I explain the performance measures graph. We using the AWK script, then calculating the graph. Now I run the X graph for packet delivery ratio. The packet delivery ratio is here. So I run PDR dot X graph. This is packet delivery ratio of our process. Next one is I find the delay graph. This is delay of our project. Next one is an energy consumption of our project. This is energy consumption of our project. Next one is an throughput of our project. This is throughput of our project. The throughput is increased. The neighbor node estimation. The neighbor node estimation algorithm is used to find the node, then the neighbor node, that node, x-axis, y-axis, and then the distance of node. If the 0 node containing the 2 is on a neighbor node, for example, that node is placed on a x position and the y position, then distance of 0 to 2 between is. Thank you.